So in section 3, we're going to be talking about multiplying and dividing monomials. Before we can talk about our rules for multiplying and dividing, we first need to know what a monomial is. So a monomial is a number, a variable, or a product of numbers and or variables. So we have a couple of examples and non-examples here for you. So examples of monomials would be 80, could be x, or could be 8x. Not examples would be x plus 5, or x squared minus y squared, because we cannot have any addition or subtraction. So you can multiply, but you cannot add or subtract. So now that we know what a monomial is, we're going to talk about our product of powers property first. So that's when we are multiplying. So we multiply powers with the same base by adding their exponents. Now notice it says same base. They must have the same base in order to add our exponents. Just a couple of examples here for you, both in symbols and in numbers. If we look at the numbers, because that seems to make a little more sense. 2 to the 4th times 2 to the 3rd equals 2 to the 4 plus 3, which is 2 to the 7th. So our final answer would be 2 to the 7th. So again, when you have the same base, we add exponents. So, first example here, find each product expressed using positive exponents. 4 to the 3rd times 4 to the 8th. So same base, always check that first, same base. 4 to the 3 plus 5, which is just 4 to the 8th. You don't really need to write this middle step here, but just showing it to you so that you have that in your notes. So it's 4 to the 8th. Part B, we have 6 times 6 to the negative 4. Now keep in mind here, if it's just a 6, it's really 6 to the power of 1. So 6 to the 1 plus negative 4, which would give us 6 to the negative 3rd, but we want to express using positive exponents. So going back to last section, that would give us 1 over 6 to the positive 3. Now notice our little watch out sticky note. When multiplying powers, we do not multiply the bases. So if we had 6 to the 1st times 6 to the 4th, that gives us 6 to the 5th, not 36 to the 5th. That's why our bases stay the same. And if we think about this, just to show you here, we have 4 to the 3rd times 4 to the 5th. So 4 to the 3rd would be 4 times 4 times 4, times, then 1, 2, 3, 4, 5 fourths for 4 to the 5th. So my base is 4 the entire way along. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So that's where that 4 to the 8th came from, keeping that base of 4. Okay, so a couple more quick examples. Find each product expressed using positive exponents. So t to the negative 5 times t to the 3rd. So using that same idea as the last couple examples, but now involving variables. So if we just add these, negative 5 plus 3 gives us t to the negative 2, which we would then rewrite as 1 over t to the 2nd, so that we have a positive exponent. And then our last example, 2x to the 3rd times 8x to the 4th. So we have our x to the 3rd and x to the 4th. That's our same base pieces. So we know that x to the 3rd and x to the 4th, same base, add the exponents, 3 and 4 gives us a 7. Now we have these coefficients out here, our 2 and our 8. We want to actually multiply them. They are not same bases, they are leading terms. So 2 times 8 would make it 16. So final answer is 16x to the 7th. Notice that we broke that one down into 2 different pieces. Multiply our coefficients of 2 and 8, and then add our bases for x to the 3rd and x to the 4th. We should never leave it 2 times 8 times x to the 7th. That is not fully simplified. Okay, now we've done multiplication. Let's talk about dividing. So our quotient of powers property. Divide powers with the same base by subtracting their exponents. So we look at the example, 3 to the 6th divided by 3 to the 2nd. Same base. So we would subtract them, so 3 to the 6th minus 2, which would give us 3 to the 4th. Okay, so looking at our first example here. Again, always double check that we have same bases. So 8 to the 5th divided by 8 to the 3rd. So we have 8 to the 5 minus 3, which is 8 to the 2nd. Positive exponent, so we're just going to leave it 8 to the 2nd. In part C, 2 to the negative 2 divided by 2 to the 2nd. So 2 to the negative 2 minus 2, which would give us 2 to the negative 4. I want a positive exponent though, so 1 over 2 to the 4th. Now there are a couple other ways that we're going to talk about some of these problems where we end up with a fraction, but for right now, I want you to think about these steps where you're subtracting our numerator exponent from our denominator exponent and then simplifying where needed. Okay, so part D, we have d to the 5th over d to the negative 2. So we think that through, that's d to the 5 minus a negative 2. Same thing as plus a positive 2, because remember we add the opposite, which would give us d to the 7th. Okay, so moving right along, a little practice there with our division powers. The table shows the approximate diameters of Earth, Mars, and Neptune. About how many times as great is Neptune's diameter than Earth's diameter? Okay, so how many times bigger is Neptune than Earth? Well, if we want to know how many times bigger, or how many times as great, this is talking about division. So we're using our quotient. Write a division expression. So our larger Neptune, so 2 to the 15th, over Earth's diameter of 2 to the 13th. So there's our division expression, which we would simplify then, same base of 2, so we subtract 15 minus 13, which gives us 2 to the 2nd, and then if I actually wanted to evaluate, that would be 4 times greater. Okay, in part 5A, about how many times as great is the diameter of Earth than the diameter of Mars? So same idea. Diameter of Earth, 2 to the 13th, divided by diameter of Mars, which is 2 to the 12th. Same base, subtract our exponents, so 13 minus 12 gives us 1, which is 2 to the 1st, or just 2. So Earth's diameter is 2 times larger. All right, and one more word problem here. The diameter of a small asteroid is 10 to the negative 1 kilometer. The diameter of Ceres is 10 to the 3rd kilometers. About how many times as great is the diameter of Ceres than the diameter of the smaller asteroid? So how many times as great? Again, we're talking about division. So 10 to the 3rd divided by 10 to the negative 1. 3 minus a negative 1, so 10 to the 3 minus negative 1, which would be 10 to the 4th, or that equals 10,000. So Ceres is 10,000 times larger. Now be careful when we have word problems like this that you're dividing the correct way. We wanted to know how many times as great is the diameter of Ceres than the diameter of the smaller asteroid. So Ceres came first. If that had been rewritten as how many times as large is the smaller asteroid than Ceres, then we would have to flip this and we would end up with a much smaller number. So Just be careful of order when we are working with word problems. Okay, so in this lesson, we worked with multiplication rules and we worked with division rules, where we add and subtract our exponents. So now we have a couple of problems for you to try. So 5a to the second times negative 3a to the negative 4. And then the second one, 6b to the negative 4 times 2b to the second. Make sure you rewrite with positive exponents only. So that will give you a little more practice from last section as well. And then to practice your division, write and evaluate an expression for the following statement: the quotient of 10 to the 6th power and 10 squared. So write the expression first and then evaluate it. We'll be looking for 2 parts on that second question or second part. All right, that's the end of this lesson.